Well, good morning or good evening to those of you who have connected in from Europe. Welcome to today's webinar, Mitigating External Force Threats. This is part of an ongoing series of infrastructure and asset related webinars that have been put on by ConnectMe. And during the course of these previous webinars, a subject that kept coming up was external force threats in right-of-ways, utilities and energy right-of-way corridors in particular, oil and gas, and other utilities. So what we did was we put together a brief, very pointed webinar. We won't keep you long today, and we hope it's really fulfilling. We got some really great content, and this is going to run about 90 minutes or a little longer, depending on how many questions you have. And that's key to this as well, is the questions you have for the presenters. It helps forms these webinars and helps them focus the content on the fly. So we're actually going to start off with a couple of polls. That asked the director to put the first poll up. If you could fill this in, we'll give you a couple of minutes on this. To put a little context into this webinar, what's meant by the, mitigating the external force threats. When it comes to energy and utility corridors, let's say oil and gas pipelines, we're all, familiar, those in the related industries are familiar with, things like external corrosion, internal corrosion, stress, cracking, flaws in manufacturing and construction, equipment issues, operational errors. These are all sort of threats to that infrastructure, but the external threats, the subsidence, extreme weather, climate, the hydrology, this is what we're focusing on today. To put into a little context, we'll give you another moment to fill in this questionnaire. Put into a little context on this. People say, well, there's more of this going on all the time. Well, there's reasons for that. Since the year 1900, the population in the United States has almost tripled. And that means a lot more pipelines and a lot more right-of-ways, but also a lot of human activity. Think of all the development going on and what that has done to the hydrology profiles around, think Western Pennsylvania, which one of the examples today, where there's a lot of pipelines, a lot of population, and a lot of surface runoff and hydrology issues in those hilly areas. So if you could put up the results of the poll. Okay. So the question, how is your company managing these external threats right now? Identifying, prioritizing, planning strategies. Using an external engineering firm, about 13%. LiDAR and remotely sensed data, a vendor is the largest, and actually that's going to be a focus of today's presentation. In-house geotechnical teams, a quarter of the outfits have those teams themselves. Surveys and boots on the ground and inspection. And then there's quite a chunk here with no formal program in place. While the survey and boots on the ground, I'm a little sad. I'm actually a surveyor in the energy and utility sector. Okay. So if we can close that and open the next poll. Okay, I wanted to ask this up front because this will help us focus the conversation later on. What are the common external threats to, in your experience, to your infrastructure and the infrastructure you work with or consult on? Landslides, flooding, seismic activity, Washington State, that's actually an issue for us here and in parts of California. The erosion, the depth of cover changes, water ponding and pooling, or any others. If you have any others, mention those in a question to the presenters. So while you're filling that out, I want to fill you in on today's format a little bit. We're going to have 4 brief connected presentations. You can ask questions at any time, but use the Q&A box at the bottom of your Zoom window there. We ask that you do that, not the chat box. The chat box, maybe if you have a question for the director, a technical issue with your connection or something, but please use the Q&A. We're going to hold most of the questions to the end of the presentations today, but after Bryan's presentation, we may answer some of those, have him answer some of those questions, as he's going to have to leave us early today. So if we could look at the results of the poll. Okay, landslide to be expected, and that's part of the focus of this presentation. Landslides, flooding, as I said, the hydrology is a big key issue. Water ponding and pooling. Seismic activity expectedly low, but it's something that has to be considered. And the erosion and depth of cover. Well, water is everything, and it certainly is in a lot of these hazards. So let's open up the slide deck. I want to do some introductions and give you an outline of what we're going to be talking about today. Again, if you've just joined us, this is the webinar on mitigating external force threats. We're going to cover identification, prioritization, monitoring, how these are done, these threats to the infrastructure in your right of way. Next slide, please. Okay, we've got some great speakers today. There's going to be 4 sections. Others will be joining some of these speakers, but in general, we've got Jeff Wiese, who I'm really happy to hear from today. I've always enjoyed reading and hearing his insights. He's a consultant and member of several boards, and really a thought leader in this sector, particularly like oil and gas. We're going to have Bryan Crowe, who's the Chief Operating Officer of Cureton Midstream, going to give us some real-world examples. And then we're going to have Kraft and Jake Opdahl from Teren, who's a fairly prominent firm in performing this sort of mitigation studies and examinations for clients in this sector. So Teren, you might be familiar with the firm Solspec. Well, Solspec is now called Teren, which I think is actually a more appropriate name. The objectives today, we're going to start off, Jeff is going to talk about the regulatory integrity drivers, building a case for implementing these programs. So we'll also go into some case studies, real world examples. And then Kat is going to go into a bit of the geek end of it, which I'm very interested in, is the actual dynamics of what's going on with these force threats. And that leads into how they're detected and how you can do a program with it. Jake will talk about that quite a bit. So I want to invite our first speaker up, our keynote speaker, to talk about the regulatory side of it and the big picture side. Jeff Wiese. Jeff, if you could turn on your camera and your microphone and take it away.
I believe it's on. Yes. Okay. Very good. Gavin, thank you so much. And that we were maybe a little over generous in your introduction, but I'll give the lowlights of that in just a second. I first wanted to welcome everybody to the webinar, and then secondly, to thank my friends at Teren for inviting me to come and speak with you and get to share the stage with Bryan and Kat and Jake. So thank you so much for that. Very experienced team. And I think Bryan's case example I previewed it, and it's great. So I'm looking forward to that. Just a couple of sentences introducing myself for those of you who have not had the chance to meet. And I look forward to that when we get out of this virtual world of working from home, right? So I've spent about 35 years in oil and gas related activities. A lot of it as a regulator, U.S. regulator, first in offshore oil and gas and second in onshore pipelines. I spent about, I don't know, probably like almost 20 years there in pipelines. And during that time, I ended up as the head of what's the Office of Pipeline Safety there. So it was a great tour. Spent 10 years doing that job and really enjoyed it. Decided to leave and ended up being a consultant, board member, senior advisor to a number of different companies, and very much enjoyed that. I focused my time largely these days on safety management systems, but that's a story for another day. Wanted to give a punchline. Really, I think what I'm doing today, speaking with you, is to kind of frame up our discussion a little bit by focusing on sort of the criticality of rigorous risk management. I'll go into a little bit of history first and then close with that punchline. So if we could go to the next slide. So I'm backing up a little bit here, and we were talking the other day about this and reminded me that many people talk about pipeline safety as compliance, and I, of course, see it as more than compliance. And compliance is not really that helpful once we get into risk management. I'll tell you why. But if you didn't know, the Federal Pipeline Safety Code has been around well over 20 years, actually a lot longer than that, but it was based in ASME standards written by the industry itself. So I would just say that over my period of time with them, I've personally witnessed the evolution of that sort of prescriptive standard into something that's increasingly performance oriented and based in risk management. The kind of flying the ointment on that one is that when you go that way, which the industry has long supported, it really requires you be able to prove your basis, right? So whether it's systems, materials, and environments, which we're really going to dive into, it's got to reflect the operator's unique situation. And we know that the federal standard applies across all states, and then some states, depending on the kind of infrastructure we're talking about, apply additional regulatory requirements. But I did want to say the reason I think that it's useful to move in this direction for everyone concerned, and I've had a firsthand view into this, is that it's getting increasingly hard to move federal regulation and keep up with the pace of change. I won't delve into it, although I'm happy to answer any questions on it, but the process has just slowed remarkably, and it usually doesn't slow at the first step in the process, which would have been, in my case, most recently, agency known as PHMSA, Pipeline Hazardous Materials Safety Administration. Next slide, please. So I thought it might be useful to drop back just a second, talk about the fundamentals of risk management. I think we all understand the frequency and consequence multipliers that add up to talk about risk. But risk management, done in a rigorous way, requires a lot of thought and being very proactive. There's no compliance on this. So remember what I said, you need to be able to prove this. So I'll come back and say this later, but it's useful to say, you know, after offshore and onshore being in risk management most of my career, I'll tell you that you can boil it down to knowing your system and knowing what's around your system. And again, we'll come back to that in a second. But you really need to know, and some of the rules that have finally come out are now pushing for greater specificity, because we saw a number of accidents. I could list off half a dozen right now, but I won't. I would just say these were large accidents, you know, in many cases, multiple fatalities, a lot of environmental damage. And in the end, when the root cause was determined, the operator clearly did not understand their system, you know, whether it's materials, the susceptibilities of the vintage of pipe they were using, its history, et cetera. Plus, I think once you began to look at preventive mitigative actions, it turned out that it was not a very rigorous application of those and considerations of things that were available. But I will say that we'll see, and I'll close on some statistics for you, not to bore everyone, but just to point out that one of the main threats to gas utilities and transmission lines is third-party excavation. I would include actually first and second-party excavation in that as well, and natural forces, other outside force damage. I also want to say one of the drivers that I've seen over my career has been what I've come to sadly know as the vicious cycle. It's that there's an accident, the local senator, congressman, politicians, be who they may, have a platform for standing up and saying not enough is being done. Then every 4 years, the legislation underpinning pipeline safety is reauthorized by Congress. The member steps forward, puts in a mandate to PHMSA to create a new regulation, right? And so then you move on with that, and it takes forever, as I mentioned. But the majority of the costly new requirements, honestly, can be traced down to a risk management failure. So I understand the challenge that we're having balancing costs and benefits, but these are definitely the facts. So next slide, please. So again, as I said earlier, current code is really a blend of performance and prescriptive requirements, but you need to be prepared to prove that you know your system and what's around it. Fortunately, the code is also allowing operators opportunistic methods for gathering that data. It may be a topic for another day, but there are unique susceptibilities and threats. And I think that one of the punchlines is leading me to the next speaker is just saying, not only do you need to know how system failures can affect what surrounds your pipeline, but you need to know in much more detail about how what surrounds your pipeline can affect your system. The whole idea of interacting threats, we can go into that if anyone has questions on it, but that really emerged like about 10 years ago, and it began getting a lot of attention. So risk management is getting far more quantitative. And as I saw when I first began in the pipeline world, using industry averages just no longer acceptable. I think your regulator will balk if they push and find that that's your basis. So you're going to need documentation on which to base it. So as I said, the inspectors increasingly are all from Missouri. Show me, right? And Bryan said something the other day I thought was really very enlightening. It's true, that integrity management program, which those of us in the pipeline world are intimately familiar with, took operators a lot of the way there. But next slide, please. I want to tell you, and I'm not doing this for shock value. I just wanted to reiterate there are real consequences to failures in the pipeline industry. And these create opportunities for detractors, politicians, media, you name it, to really weigh in. So over the course of, actually, I think that's 2021. So over the course of 20 years, what you can see is nearly 5,800 significant pipeline accidents. These are the ones that are reported federally, 260 fatalities, 1,100 injuries, and $11 billion in damages. And my guess is that's an undercount. Next, please. I thought I would close out my comments to you and turn to Kat in a second by saying, kind of looked at the breakdown of these reported incidents over 20 years. And I think these are very large and not all encompassing buckets. But corrosion, I don't think anyone would be surprised by that. But when I was talking with Kat and Jake the other day, when I mentioned natural force and other outside force damage, I think those are really underrepresented, because what you see in 30% for material and weld and equipment failure, my guess is a lot of that is interacting threats. And so there's an environmental component to it. So thank you for your time and attention. Let me turn it over to Kat.
Hi, thank you very much, Jeff. Really appreciate that overview, and you provide a unique perspective on pipeline integrity and the emerging issues surrounding natural forest threats. So as Gavin mentioned, my name is Kat Kraft. I currently run product strategy and ESG initiatives here at Teren. My background spans natural resource science, policy, and economics, and I've gathered that expertise through working for tech startups, research institutions, engineering firms, and state and federal government agencies over the past 20 years or so. So thank you very much for spending your time with us today, and I'll dive right in. As Jeff mentioned, traditional pipeline integrity has spent much focus over the last years and has done a good job of addressing a lot of the major threats that are related to structural and material pipeline integrity. As exhibited here by this graphic published by Enbridge at a recent PHMSA Research and Development Conference, integrity management when it comes to natural forest threats has been largely lagging in multiple dimensions. Stacy, next slide. So this is a pretty big deal, as natural forest threats are increasing in size, frequency, and intensity year over year as a result of climate change. In 2021, there were 20 weather or climate-related disaster events in the US, with losses exceeding $1 billion each. Floods, wildfires, hurricanes, tornadoes, heavy precipitation events, these all threaten pipeline safety and integrity. And let's focus a second on that last factor for a moment, the heavy precipitation events. Heavy downpours are increasing nationally, especially over the last 3 to 5 decades, with the largest increases happening in the Midwest and the Northeast. Increases in frequency and intensity of the extreme precipitation events are projected for all US regions. And this is a pretty big deal because heavy precipitation increases the risk of landslides. So when above normal precipitation raises the water table and saturates the ground, slopes can lose their stability, propagating a mass soil movement event. And we'll dive in deeper to the mechanics of that here in a bit later on in the presentation. Next slide, please. So to illustrate that increase in landslide-related threats and external force threats, Teren collected data over the past 5 years to demonstrate how those effects of heavy precipitation are impacting pipeline stability. So our study took place in the hilly Appalachian region, where we've classified and tracked over 6,000 geohazards, spanning nearly 3,000 miles of pipeline right-of-way. USGS records, or United States Geological Survey records for that region, indicate that landslides have historically occurred at an average slope of about 76%. So pretty steep slope. Our data, however, from the last 5 years reveals that landslides are now occurring at an average of 58% slope. So that's a change of almost 20% slope average on which landslides are propagating. That's pretty major. The takeaway here is that the landscape in which we are operating is indeed changing. The way we have identified and managed threats to pipeline safety in the past is now insufficient for today's world. And moreover, historical data cannot be relied on to guide current and future risk management programs. The environment's changed. And that requires us to change the way we manage the modern threats to infrastructure. And the oil and gas sector has long embraced digital technologies for the management of pipeline integrity, but the management of external conditions on which pipeline stability depends has largely been left out of that digital transformation. And that is where Teren has developed its niche and sought to help operators over the last several years. And we've done so providing safety improvements and cost savings to numerous customers throughout the process. And I'll illustrate that in a minute. And then I'll pass the baton to Bryan, and he can speak to a case study of external force threat management through data. All right, next slide, please. So here's an example of some of the work that we do at Teren. On the left, you'll see where the image at the far left corner, you'll see where we mapped problematic hill slopes with the potential to slide and impact the pipeline. So we do a system-wide analysis, analyze hill slopes that are connected to a pipeline, and then identify and prioritize which hill slopes connected to the pipeline would be most likely to fail and have the highest consequence for that pipe. We identified this particular hill slope in the image as being in the 95th percentile for a slide impact potential. The operator at the time chose not to mitigate the hill slope, and a few months later, a heavy precipitation event propagated a landslide that took out the pipe. The event cost the company many millions of dollars as the line was shut in for 6 months. And the operator since has worked with Teren to establish a right-of-way integrity management program across their system, and they've had 0 landslide associated shut-ins since. So a success story for an operator there. Next slide, please. All right, so that'll wrap up my section for now, and I'll come back later to talk about the mechanics of Earth movement. In the meantime, I'll pass the baton to Bryan Crowe, who will be talking about a case study. Thank you.
Thanks, Kat. Hey, everyone. My name is Bryan Crowe. I'm Chief Operating Officer for Cureton Midstream. I've been in the midstream industry for a little over 20 years now, operating assets all across the U.S., Texas, Southeast, Marcellus, Colorado, Utah. So I've got pretty wide range of experience across all these different assets. I'm gonna step back in time a little bit, about 6 years ago. So I'm in West Virginia. I'm standing on top of a pipeline. I'm looking down the right of way. One of our pipeline technicians had done a locate, just put down some pipeline marker flags, some temporary flags, and really noticed a strange bend in the pipe. So this pipeline right of way had 3 other pipes in there. Behind these pipes was one of the largest gas processing plants in the world. So, shutting down this line would be pretty significant. We'd be shutting down gas to an entire region, resulting in a state of emergency for neighboring states. And, at a huge cost to both the operator and our upstream producer customers. So, it's literally tens of millions of dollars a day in revenue that you're looking at shutting in. So it's a tough decision, and you want that data behind it, right? So this particular decision to shut it in was complicated because of a lack of that data. It was difficult to determine if the line had moved or if it was under stress from outside influences, because there wasn't really an evident landslide that had taken place. So, we've seen a lot of landslides in the area. A lot of them are the translational landslides where the whole hillside just kind of comes off. This one ended up being a rotational landslide, so it was really difficult to see. So we're up there. We're trying to convince ourselves that a contractor must have came through there and laid around a big, large rock formation or something. It's not uncommon to find boulders the size of Volkswagen Bugs in this area. So it was, we pulled our as-builts out. As-builts showed a straight line. So then we were questioning, maybe the surveyor didn't shoot it in correctly. But, we really can't do that because that's the only data that we had. So we couldn't attribute the bend to that. So really out of abundance of caution and the great safety culture that we had, we decided to shut the line in. So we started taking some soil off of this pipe. And as soon as we started to remove the soil, we noticed movement on the pipe. So, we knew we had a big issue and we knew it wasn't something the contractor did. So we ended up having to replace, I forget, 1,500 foot of right of way, completely rebuilt the right of way all the way down to the toe. We had to replace all 3 pipelines in that right of way. It was a huge effort. Due to our amazing teams and contractors, we were able to get all this done in pretty short order. I think the total turnaround from the time that we shut in, got everything back in service, was around 10 days. I probably lost 10 years of my life in those 10 days. Just trying to get this thing turned around. And it was a huge cost. It was a huge cost to us, our producer customers, as well as consumers of the energy in that region. A lot of people don't realize how their energy is produced. And when you go and take 3% of natural gas production offline, it has a significant impact. And what was really amazing was, had the contractors or had we had enough foresight to just properly install a drain tile system, we would have mitigated this whole thing. So like I was saying before, the slip wasn't incredibly apparent. It was large rotational slip, started well off the right of way. It wasn't easy to see by the naked eye. We had done foot patrols, we had done aerial line patrols. There was really not a scarp that was visible. Sometimes right away reclamation, they can come through and smooth some of those things off. The grass growing in heavily wet areas is a little bit easier to get that regrowth, so it covers some of this stuff up. So it wasn't super easy to see. And for me, that was really alarming. We can go out there, we can do our full integrity management program, we can run smart tools, have all the cathodic protection in the world and still not be detecting this huge risk to our asset and not properly quantifying what that risk is. So much of integrity management has been focused from the inside of the pipeline out, but the amount of new lines going in to these challenging right-of-way areas has introduced really a new threat of outside influences. And these influences, they start well off the right of way. I mean, they can be a couple 100 feet off the right of way. They could be underneath tree cover where an aerial pipeline patrol is not going to be able to see it very easy. So we knew that we had to find a better way to calculate these risks and mitigate them. We never really wanted to be stuck in that decision-making process again. Because it is very tough to make these decisions that have such large repercussions without having some data behind it, right? Can you go to the next slide? So, shortly after this, we went and partnered with Teren to do a case study with their aerial detection and analytics suite that they have on one of our areas of operation. So, we wanted it to be controlled. We had just got done doing surveys and walking around 300 miles of pipe in a certain geographic area. So we selected that 300 miles of pipe of business critical assets. And we had already determined that there were geohazards present. So we wanted to kind of see how many that they could capture. Are they going to miss any? Can they see stuff that we can't see? So we really did kind of this blind test with Teren. The second part of it is we really wanted to get a baseline of where our pipelines were and a baseline elevation profile so we can go out there and see if we have any movement over time. So the first 300 miles, we had about 246 unprioritized slips that we had found. Out of these 246 slips, I remember getting a spreadsheet and looking at them like, okay, which one do I go after first? There's 246. I'm not going to be able to go and fix 246 of them. So there was no real way to classify severity or determine which ones to fix first without, getting a geotech survey crew out there and spending a lot of money and time trying to figure out which ones were most critical, which ones were business critical, which one had the biggest impact to safety of our neighbors. So it's just very overwhelming. Up to this point, we'd been averaging around 3 to 5 shut-ins a year due to slips. And these were costing us somewhere, around $7 million a day in lost revenues between us and our customers. It's not just the midstream that you're looking at here, but you're shutting in production to the well pads in these regions. So it goes all the way back to the royalty owner. So it's a huge impact shutting in these pipelines and these assets. Teren flew the area and through their slip detection algorithms, can you go to the next slide? They found 12 slips that we weren't able to find on our foot patrols. We had one of the rainiest seasons on record, and we didn't incur any shut-ins that year. We were able to reduce our repair budget almost 90%. And how we were able to do all this is we were able to repair a lot of these landslides and slips and potential slip areas before they turned into a catastrophic failure. So really by switching from the reactive mode that we were in to a proactive mode and maintenance program, we were really able to reduce our costs. So, on average, we were spending somewhere between $500,000, $3 million to go out and fix a landslide. And, we were really able to drive that cost down to now you get a crew going and you can go and hit 50 sites and it's $10,000 a site to go out and re-divert some water or put a drain tile in, or it's just a lot cheaper and it's a lot more manageable. And also the other part of it, we were able to prioritize our active slips and put together monitoring programs. So what I mean by that is we were able to say, what, this slip is here, but it looks like it's been here for 5 years and it hasn't moved. So we're just going to monitor it. We're going to come out every month and see if anything moves. We're not necessarily going to go in here and rebuild this entire hillside for $3 million. Or we're going to say, this is a brand new slip. There's a ton of water here. This is something that's a high priority for us, and we need to get in there and we need to get it fixed. And what we noticed is by doing that, our maintenance program started really paying for itself. So just the avoidance of one major geohazard, we were able to effectively fund our entire maintenance program and monitoring program that we had. And also by setting up the normal interval routine flights and data collections, you really kind of get in front of these issues. So the program that we had set up is effectively, we went and flew our baseline, and then every fall or spring, we would go back out and fly it again. And from that flight, we would determine if we had any movements, any new landslides. We would also monitor. And we also created like a program to where if we had a huge rainfall event, we would go out and fly after that rainfall event in certain critical areas to ensure business continuity and really protect our business critical assets and anything that had a major impact to the public. So those programs, it really increased the safety overall of our assets and increased the safety of our people, because we weren't having people go out and walk these mountains in West Virginia all the time. So it was really, really a huge benefit to us overall, and something that we saw a ton of success from. So that's all I have. Is there any questions for me? Because like they said earlier, I do have to hop off. If not, I'll turn it back over to Kat.
Hey, Bryan, this is Gavin. Yeah, we've got some questions for you. There's a particular technical question about the remote sensing type that I think I'll hold for Kat towards the end about SAR data. But questions that came up during your presentation. One is, what do you find the state of the as-built? How far off are the pipes when you actually locate them?
Yeah, so, we had acquired some assets that didn't have the best as-built in the world. Sometimes you can mix up your files, and your IFCs, your issued for construction drawings, can get mixed up with your as-builts. So if it looks like it's really close, but you go out there and just like I was talking about that Volkswagen bug boulder that's in the right of way, they have to go out and lay around that thing because it's a whole lot easier to lay around than try to blast through it. We saw that happen quite a bit. It's gotten a lot better as technology's gotten better with shooting and stuff. Quality control's gotten better. So it is an issue. It's something you should always be checking and verifying. But as smart tools increase in accuracy, the XYZ tool is one of those great things that you can leverage to verify the accuracy of your as-builts off of your program. It'll kind of show if you have any huge misses there.
Okay. Yeah, Bryan, Sam A is asking, how would you value the correlation to the efforts with mitigation, to ESG and the ability to access capital for operators? I mean, with the higher confidence.
Yeah, that's great. It's a great question, because the low hanging fruit right now on the E part, the environmental part of ESG is emissions. And it's super, easy to see that problem. You can go out with a flare camera and see emissions. You can see heat coming off of stuff. And a lot of focus has been on emissions. It's been on going green and reducing CO2 and other greenhouse gases. And there hasn't been a huge focus yet, in which I think it will be coming. I think it's here. And there's a lot of these outside influences around landslides, external threats on assets. It's not just the pipelines, but facilities, you got flooding. There's all these environmental threats that are out there that will need to be quantified in people's ESG programs. So it's something that people should really start considering as part of their ESG efforts. It's something that, we at Cureton are definitely taking into account now.
Okay. A question about the triggers for the shut-ins. This might be a little off topic, but what triggers, the shut-ins? You detected leaks using sensors, pressure loss, or your walkthrough inspections?
Yeah. So this particular asset was a Emcee 900 liquid pipeline. So there was a lot of pressure, and there are just a lot of stored energy behind this pipeline. And if you got the weight of a mountain, like literally on top of you, and that's what's pushing down on this pipe, that's a huge amount of lateral strain that you're not really accounting for when you're building these pipelines. We build them for structure, and we build them for corrosion, and we're not like, hey, what happens if the entire West Virginia mountain comes down on this thing? Is it going to hold? And there's not really a way to properly build for that outside of mitigating that mountain coming down on you. So when we're out there and you're looking at this pipe and you see other companies around you having failures, and you see what that impact is, it's scary. You can watch the ground move and you can hear things creak. And the last thing you want to do is be on top of that mountain when an NGL pipeline comes loose, because it's just not going to be a good result for anyone. So as far as shutting in these large pipelines, just having a good safety culture and making sure that you're not taking any undue risks, and getting people out of there, making it safe before you go back in. That's just the culture that we had developed where I was at. And it was something I was thankful for. And our management allowed us to make those decisions locally, which was very nice. So, we didn't wait for a leak to happen. We wanted to be proactive and make sure that nobody got hurt. So that's how we made that decision and the lens that we were looking through.
Okay, well, thank you, Bryan. It's great to have these direct insights. You've been out there on the ground with this. I'm going to get one more question in before we hand this over to Kat. This question also, I might ask Kat about this later. The question was about if you noticed that any of your slip situations correlated with any uphill development, and would be looking at change detection in a broader area be part of a proactive strategy?
Yeah, absolutely. So, it definitely impacts your slip detection mitigation profile. So, for example, there was an area where the county had come down through and done some road work, kind of a couple hundred feet on top of us. And when they did that, they cut through a drainage tile system that was diverting water over our right of way, and they re-diverted it. And then that water started just mitigating into our right of way, which then ended up in a landslide situation that we ended up having to re-mitigate. So it cost both us and the county quite a bit of money to go through and repair that. Had we been able to capture that quicker and we were looking at that, we probably could have mitigated and saved some money on our repairs there. But definitely expanding outside of your 100-foot right of way is something that's critical. You want to be 1,000 foot both sides. You want to have a wider breadth of what's actually happening. It also helps with your risks. You can kind of see as population is encroaching on you, if you house it any more structures, new structures, maybe a farmer come through and you notice a small trench got put across you. Maybe they hit your pipe while they were crossing. There's all different kinds of things by looking at the outside influences that you are able to mitigate and properly classify the risk to your pipeline. So it's increasing that scope that you traditionally either walk the right of way looking for leaks or you fly the right of way. It's a huge benefit to the operators.
Awesome. Thank you, Bryan. And thank you for presenting. I really wanted to have real world examples, so I'm glad you came in and gave this to us. If there's any further questions, I get them to you by email or something, but I know you had to jump off early today. So thanks much. And Kat, you're on to talk about root causes.
Excellent. Yes, I echo Gavin saying many thanks, Bryan. All right, guys. So as Bryan alluded to, and Gavin mentioned in that question about looking at upslope events and other potentially correlated factors that could be affecting a landslide, I'll dive into now the mechanics of earth movement that considers some of these broader environmental factors that would help us understand the root causes of geohazards and thus potentially mitigate and address those root causes in a much more efficient and economically friendly way before a geohazard propagates and escalates in cost and consequence. So, with that said, this screen depicts the mathematical equation for hill slope stability that's used by engineering firms. And I won't dive deep into the details of this equation on the webinar, but the important information to take away from this diagram is that hill slope stability is a factor of soil particle cohesion, which is the tendency of soil particles to adhere together. It's also a factor of the angle of internal friction, which is a measure of the ability of a unit of rock or soil to withstand shear stress or slippage. It's also a factor of soil mass, which is the function of soil bulk density, volume, and gravity, the heaviness and mass of that unit of soil. And then a factor of slope. We can't usually do much to control slope, but as we'll dive into, the three factors of soil cohesion, angle of internal friction, and soil mass are influenced by hydrology and vegetation. And those are factors that we can indeed influence through our management practices. So to understand and thus manage the root causes of landslides, we must look to the hydrologic and vegetative conditions surrounding the pipeline. And I'll dive into how we go about that here in a second. Next slide. All right, so this diagram depicts an example of a forested hill slope that might represent the original site conditions prior to the installation of a pipeline or other facility. In this scenario, when heavy precipitation event occurs, it typically takes about one to 2 days for the saturated soil to drain and return to normal soil conditions. The soil does not stay saturated for long periods of time. The trees help to remove excess water through evapotranspiration, and the tree roots increase soil stability by moving the excess water on the surface into the water table, and thus increasing that because there's movement of water in the water, because there's less soil moisture. There is thus an increase in soil cohesion and the ability of those soil particles to adhere to one another, and also an ability of the soil to withstand shear stress or weight and slippage. So you have an overall increase in the ability of a land mass to remain stable as a result of the water being moved from that surface area into the atmosphere and then into the lower water table or groundwater. Next slide. So this slide represents that same slope. However, the trees have been removed. The roots are still in place, but trees have been cut. And you might look at this as, as if you were preparing to, construct a pipeline or other infrastructure on that same right of way, or on that same landscape, excuse me. So when we remove the trees, more water stays in the soil for a longer duration, and it takes longer for the soil to drain as a result. There's not any evapotranspiration happening as a result of the trees, and the remaining roots will continue to move. The remaining roots that are there, the trees have just been cut, the roots have not been removed. And so those roots will continue to move surface water to the groundwater table via those relic root channels. And thus, that will slowly diminish as the roots degrade, right? The roots will degrade over time, and the ability of those roots to move surface water into groundwater tables will eventually fade. However, right now those roots are helping stabilize the slope and reduce soil saturation. Next slide, please. So now you take that same site and you install a landslide. And I keep wanting to say a landslide. So you install a pipeline. And now that the pipeline is installed, the right-of-way has been reclaimed, but stormwater controls are either non-existent or insufficient. So this is the scenario in which the hill slope is most at risk. Now that the roots have been removed, they're no longer moving water from the surface into the groundwater, the water table through the root channels. That's a problem. You have increased soil saturation at the surface. Additionally, the pipe and the associated trench, they collect and dam the water flowing downslope. So you have more water being held in place, thus decreasing that soil cohesion and the slope's ability to withstand slippage or that angle of internal friction, while simultaneously you're increasing the soil mass. So you have that shear stress or the likelihood of slope slippage building up right at the juncture of the pipeline, which creates a scenario ripe for disaster given a heavy rainstorm. Next slide. So now you take that same site and you establish stormwater controls or erosion control devices and proper right-of-way drainage. All those same conditions from the prior scenario still apply, except that, however, now those stormwater controls are redirecting water away from the pipeline right-of-way, thus reducing the surface and subsurface saturation zones that were putting the pipeline at risk in the first place. So you still have some trenching and damming of that water next to the pipe, so that pipe will continue to be, or that site will continue to be at an elevated risk compared to when it was a forested area, but the stormwater controls substantially decrease the risk at which the pipeline is exposed. So my hope is that these slides underscore that in many cases, managing geohazards comes down to managing hydrology. Next slide. So Teren has, in addition to landslide identification, analysis, and prioritization, Teren performs a hydrology analysis to reveal functioning or malfunctioning stormwater controls or problematic hydrology areas to demonstrate and expose where water might be pooling into saturation zones that could pose a severe threat to right-of-way stability and pipeline integrity, as we just witnessed in those prior slides. Next slide, please. So here's an example of that hydrologic analysis playing out in conjunction with the geohazard analysis. So in the image on the left, we have an identified geohazard. Just looking at that geohazard, you might say, okay, that's the site we need to fix. That's where I'm going to focus my mitigation efforts. That's my problem area. When you apply a surface hydrology analysis next to that geohazard, you'll see that there's actually a lot of surface water flow that's connected to that geohazard upstream or upslope of the geohazard's location. And we can further isolate those specific problematic flow paths that where water is accumulating and saturating the soil and connecting to the geohazard in a way that's most likely to be the root cause of the landslide occurring in the first place. So now, all of a sudden, when you go to fix this geohazard that's exampled here, you could do so by addressing, you fix the geohazard, but then to prevent the geohazard from propagating once again, given another significant weather event, you would impose stormwater controls upslope where you have those problematic flow paths occurring in the first place. You could use this same scenario, ideally in a proactive manner where a geohazard has not formed, but you're able to isolate problematic flow paths on steep slopes where, if left unmitigated, those flow paths could propagate a geohazard in an unknown forthcoming significant weather event. So the operator then, by installing a stormwater device or two, is able to significantly decrease their risk and avoid geohazards that, a geohazard mitigation effort that is a significant increase in cost and consequence as a result, as Bryan kind of exhibited and alluded to in his use cases. All right, next slide, please. That wraps it up for my part of the show. I'm going to pass it on to Jake Okdahl now, who's going to chat about assessing changing landscapes and change through time, which also gets at one of the other questions that Gavin posed on behalf of the audience. Thank you very much, everyone.
Thanks, Kat. And yeah, thanks again, everyone, for joining us here today. My name's Jake Opdahl, Director of Sales with Teren. My education and career has been focused on GIS, geospatial data and technology, and predominantly the majority of my career has been in the pipeline space, working with pipeline operators to align different technologies to address particular problems. And I'm going to talk a bit today about a more holistic kind of broad brush approach to start here. This will be the focus topic on quantifying and prioritizing these threats, but assessing these changing landscapes. And also we'll talk a little bit about change through time, that fourth dimension, that temporal component, which is very important. We've heard today both from Kat and Bryan about some of this more specific discrete identification of geohazards and the hydrologic components that come into play there as well. And we can probably move to the next slide here. I'm going to talk a little bit here about a little bit of a step back, right? If we look at the case studies that Bryan presented, they knew they had some significant issues focused around landslides around their particular assets. And so it made sense to prescribe something such as the high fidelity LiDAR and the analytics that could be performed on that data to tease out those discrete geohazards. But in many cases, operators sometimes don't know the extent of risk that their assets may face based on these natural external force threats. Part of that too may be related to the changes we've seen, the climate changes, the increase in heavy precipitation events, the increases in hurricanes, and the force in which these different events have been exacerbated as well. And so in some cases, there may be pipeline assets that previously were somewhat stable or not as susceptible to these environmental threats. Whereas now with a changing landscape, this is something that we need to pay attention to. So in a lot of our conversations prior to prescribing something like high fidelity LiDAR, often an operator wants to take a step back and say, where really are the risks? Where do I need to put this focus for my assets? And so you can see here in this graphic, and what I'm going to be talking about is, again, focused on from a pipeline operator's perspective, right? But these same concepts and methodologies really would apply to any industry or any market where you're managing assets on the Earth's surface that, again, could be susceptible to these threats. So the graphic you can see here, it does a good job visually of showing us that relative threat, right? And in this case, posed, say, by these problematic hill slopes, right? You can see in the graphic where there's along that pipeline where it's red, the high risk, right? And we're able to take and compile a bunch of data, which I'll get into here in a minute, and start to summarize that to the pipe center line itself, in this case in 3-meter segments using sliding mile analysis, to really tease out where these threats are. In this case, again, based on a problematic hill slope and related to geohazards. We'll talk about other potential threats and some other risk layers as well. And if we move to the next slide, here's a few examples, right? And I'm going to touch on a few of these here in the presentation. But we can see now graphically by leveraging different data sources, right, to start to tease out this information where these high risks are. And a few data points, some metrics here, focused on the lower 48 here within the United States. 925,000 square miles of landslide high risk potential, right? River scour, 133,000 square miles. Inundation for flooding, over 800,000 square miles. Subsidence based on karst topography, 225,000 square miles. And this is across the United States where there's 562,000, give or take, miles of pipeline. So a lot of infrastructure here that obviously operators want to keep safe, the public wants to keep safe. So we can start to look at these different risk levels from these different risk types to get a better sense, again, where to prioritize those mitigative efforts. Next slide, please. So in this case, we've talked a lot about landslides, and these different risks apply certainly in different geographies, right? Obviously up in the Northeast in the Appalachian Basin, where the case studies that were presented earlier took place, very hilly, very susceptible to landslides, right? So we can start to see, though, across the entire nation, in this case, a graphical representation looking at that landslide threat. And again, summarizing that, and in this particular case, working with an operator, they found they had over 1,000 miles in that 25th percentile of landslide risk, all right? And we're able to do this by utilizing data inputs that really speak to what Kat had presented before on some of the mechanics behind this, right? Looking at elevation data, looking at soil types, soil databases, looking at the hydrology and how the analysis of that terrain will affect the surface hydrologic flow. And all of this then can give us a picture where we can start to say, all right, where are these high risk threats? Next slide, please. We've probably all seen pictures or videos of a house being swallowed up by a sinkhole in Florida, right? So karst topography has a high risk then for subsidence. So another potential risk type to these assets. In this case, a different geography, and we can see on the right when we look at the rasterized data set for that high risk in Florida, for example, in the southeast there, where this karst topography is very prevalent. And then summarizing that again to center lines, and in this case, an operator with a number of miles of pipeline within these geographies found that they had over 1,200 miles in that 25th percentile, that high risk for subsidence threat. Next slide. So want to talk a little bit about depth of cover. And for those of you, if that term may be new, right, again, in regards to pipelines in the lower 48, we bury the pipelines, right, keep them safe. And we want to keep those pipelines buried. We want to have soil on top to keep them safe, right? So depth of cover really looks at how much soil then is on top of that pipe. How much cover do we have? And with soil loss, different types of erosion, that pipeline can become exposed and then certainly at much higher risk for an incident to occur, for something really bad to happen. So you can see in this case, a lot of this is predominant within the Midwest. And these particular threats can come from a number of different root causes, roads, development, things of that nature. Agriculture is a big player here when it comes to soil loss. And you can see there within the Midwest where we've got a lot of agriculture, visualizing there the depth of cover threat. And in this case, we have a case study here, an operator with a very large footprint of assets, and much of that within this particular geography, over 7,000 miles of pipeline, subject to that potential depth of cover threat. And again, same methodology here, right, where we're taking various data sources, remotely sensed data, different soils databases, looking at wind scour, things of that nature, to then run these analytics and then tease this information out to give a asset manager this broad brush holistic view of where to focus, right, to again mitigate those threats. Next slide. So we've touched on a concept here throughout the presentation a little bit about change detection, about that temporal component, looking at change over time. So when we kind of circle back here to some of the technology and concepts that were presented before, when we look again at these discrete geohazards, identifying that through different analytics, utilizing the high fidelity LiDAR data in this case as the input for that, we can go find these discrete geohazards. Now, these slips, these landslides, some of these may be decades or more old, right? And they may be dormant. Some of these may be new, again, based on removal of soil due to construction, a new right-of-way put in, the water bars or stormwater components have been affected in some way or another. So with repeat acquisition of this high fidelity data, this LiDAR data, checking each of those geohazards over time, we can start to now tease out change over time. And you can see in these graphics here, where in the spring of 2020, these two geohazards were identified. In the fall of 2020, we can see that they have actually now merged, right? So there's been significant movement, and we can see here both from the toe slope and the scarp slope the changes in soil volumes, right, along this pipeline. And so this really now starts to inform us with some really important information beyond just finding a geohazard, whether that's done via LiDAR, whether that was found boots on the ground and identified. Looking at this change over time can now really inform and again help to prescribe where those mitigative efforts really should be focused. Obviously, this geohazard has merged, it's growing, it's moving, it is directly now on top of this pipeline. It's definitely something that this operator then would want to address as quickly as possible. So that temporal component, that fourth dimension here really starts to again inform and provide this actionable data and information. Next slide. We've also heard here throughout the presentation, and it's come up a few times, about severe weather events, right? Again, going back to looking at these increased frequency and increase in, severity of these weather events, heavy precipitation event. We're starting to see in conversations with those in the industry, right, a need for more near real-time monitoring of these assets and of these geographies. When we look at the RIM Essentials, which was the broad brush application looking across the entire US, that's pretty static, right? When we look at the RIM Premium, which was the LiDAR-based analytics, this is more dynamic, but it's something typically performed twice a year, right? In the fall and in the spring, when there's leaf-off conditions, LiDAR data performs best then, and we can, again, have this dynamic and tease out these discrete geohazards. But what about in between, right? Weather doesn't necessarily participate in the calendar and the scheduling for LiDAR acquisition, and these storms come through, and this presents, certainly new, greater risk along the pipeline or along these assets. So with something like RIM on demand, being able to put that fixed wing aircraft up in the sky with a LiDAR sensor to be able to go acquire data in a near real-time environment and then run those same analytics, we can now again inform operators on changes and again where to send those boots on the ground. Traditionally, a weather event, that might be what is the current procedure for an operator, is to send out inspectors, which they may be understaffed, they may not have the number of inspectors they need to really meet some of these requirements to go visit these sites within 72 hours of a extreme weather event. And even if they do put a aerial patrol in, this is again, someone that looking out in a very subjective manner, right, to tease out, is there a problem? Is there something we need to do here? Well, again, if we can put some of these technologies in place to utilize that high fidelity data and utilize the analytics and do this in a very rapid manner, which should certainly be mentioned here, the ability to not only capture LiDAR data, but then to process that LiDAR data very quickly is something somewhat new. For those of you who have worked with LiDAR data, it is big data sets, takes a lot of massaging to get that point cloud to something usable. The ability to process that quickly and then, in this case, automate the ability to run these analytics to find these issues really plays into, again, some of this more near real-time monitoring and what can be done then to, again, mitigate these risks. Next slide. So, hit on a couple of key takeaways here. We've had a lot of really wonderful presentations here and some great information presented. The environment is changing. The regulations are changing. And we found more and more this need for a outside-in approach, right? Traditional integrity management, at least in the pipeline space, has always been very focused on the pipeline itself. And that's not going to change. There's a lot of really important things being done from an integrity management perspective to ensure that that pipeline is safe and operating effectively in a safe manner. But with these changes, whether it be environmental, whether it be regulatory, whether it be from an ESG perspective, operators of different pipelines or different assets, whatever they may be, they really need the ability to not only identify where these risks are, but prioritize them. As Bryan had mentioned, he knew he had a lot of slips. Where to start, right? So the prioritization here, and whether that be leveraging the real-time analytics or simply leveraging some of the decision-making algorithms that would then prioritize where to start, very key for an operator, right? To then be able to put in place a plan to take some proactive approaches here, address these issues before they become really big issues. And then monitoring that over time, as I mentioned, monitoring these environmental threats. Seeking these actionable insights again, right? It's one thing to know, yeah, we've got a problem, right? But can we provide these actionable insights, this decision-ready data in a way in which they can, these operators then can take that and implement that into their process and again, prioritize, mitigate those highest risk assets. Understanding the root cause, very important. There are some brilliant folks that I get an opportunity to work with, both internally to Teren as well as externally that work for these operators that understand that root cause, right? And the more we can understand about the root cause, the more we can then inform technologies such as the Teren program here to automate that and get this data out quickly, right? And this then helps inform those mitigative efforts. And that change over time, again, very important here, that temporal component to identify where are these hazards changing. Perhaps some of these hazards we thought were a big deal are very dormant. We don't need to focus on them right now, but we find that certain other areas, there's some significant change in the volume of soil from the toe scope to the toe scarp to along that geohazard. So assessing that change through time, again, very important component here when we look at how these technologies can be leveraged for an operator. And those are the key takeaways.
Cool. Hey, thank you, Jake. This is Gavin. We're gonna go into the Q&A segment of this. There's some questions for you and Kat and Jeff that people have put in. For those in the audience, we're going to work through the questions you've been entering during the presentations. Thank you for your patience on this, and enter any more in the Q&A box. So yeah, the previous slide was contact information for like Kat and Jake, but also be aware that this presentation will be available online as well, and contact information. So if everybody's up there, I'm going to start going through the questions. Actually, I'd like to kick in the third poll question, if the director could put that up now. Okay. Oh, here we go. Okay, so a lot of the talk has been about the hydrology, the weather, just how wet things are. There's big chunks of the country that are really muddy and slidey and pipey, and you put all those together and you've got these hazards. But the questions are to the end users and operators that are online here today. What do you do to mitigate risks after a severe weather event? External engineering firm, you have in-house disaster recovery emergency response teams, go to LiDAR and other remotely sensed data vendors, survey boots on the grounds, inspections, or do you not have a formal program in place? So while you're answering that, a question came up for Jeff from Brett G. He wanted to know about the source of that great data that you'd put up in your keynote. Jeff?
Yep. And apologies to Brett and others there. I should have put obviously good form to cite your data. I'll ask for a little forgiveness in the fact that I helped create a lot of that data during my time at PHMSA and OPS. And so I just took liberty with it, but it's directly downloadable from the PHMSA site. If you look at pipeline data, I think there's a drop down for pipeline data. You can take there and you can query it in a lot of different ways. So it's a good database. And sorry about that, Brett. I should have been more specific.
Okay, thank you. If we could see the results of the poll. This is similar to a question earlier. It looks like surveying boots on the ground are the primary right now. About 20% don't have a formal program. And then LiDAR, was no surprise, is another key option. Thank you for that. So a few more questions. This could be for Jake and Kat. What is the baseline GIS platform being used to manage the assets? And I'll add, or do you try to stay platform agnostic, to be flexible with the customers?
Sure. The current platform that we utilize as far as our viewer, and we've seen some screenshots from that, is an Esri-based platform, the predominant GIS platform used in the industries we serve. We try to be very agnostic as far as the consumption, if you will, the inputs of data. The LiDAR data that we typically use is typically LiDAR data that we're acquiring through a specific sensor. But again, we're more focused on generating those analytics in a way that can then be provided back. And we have worked with folks that are leveraging other GIS platforms as well. And our outputs can be typically consumed in those other GIS platforms as well, but predominantly in an Esri-based environment.
Okay, thank you. A question about the operations side of the process. To determine if slides are active, well, you gave an example where you do like multiple LiDAR sets to determine that it's active. You give us an example of a program you might set up, how frequently you might do the LiDAR.
Right. The majority of the programs that we have implemented within the pipeline space are typically twice a year for LiDAR acquisition.
Okay.
And that's typically done in the spring and the fall. We didn't really get into in-depth around the LiDAR technology itself, but it's most effective when there's a leaf-off situation. So the canopy of the trees, we can penetrate those laser pulses, more effectively. So typically spring and fall, twice a year. For certain other applications, it might be once a year. And then in the on-demand case, that's going to be many times, 6 to 10 times additional a year, where there might be a weather event to then go get that aircraft up and acquiring data. But most typically twice a year.
Okay. There's going to be a follow-up question to that, but I'm going to try to go in order. There's actually two related questions. I'll kind of paraphrase some of these. The questions are flooding in now, so I'm doing an amalgam of some of these. The question about integrating other data sets like in SAR. Now, SAR was going to come up because as somebody said in one of their questions, they were saying, covers a wide area, but I understand that you've looked. You do look at this, but also found that for the specific topical nature of things, that the LiDAR has turned out to be more effective in a lot of cases. Maybe you could talk about, as these questions are both focused on SAR, maybe a discussion about that.
I can take that one, Jake. So SAR, or synthetic aperture radar, is an emerging technology with a lot of promise. It's satellite based, and there are constantly more and more constellations being put up that are expanding SAR's reach and coverage. For SAR, to really extract information from SAR, you run a process called interferometry, in which you compare two kind of superimposed wavelengths together to extract information and compare changes between time 1 and time 2. So there are a lot of very applicable use cases for change detection and measurement using interferometry and synthetic aperture radar. However, as we mentioned, it is an emerging technology, and right now there are limited bandwidths that are reliably available for extracting from which we can extract data. And those bandwidths that are currently available through SAR are less useful for penetrating vegetation and developing out subtle, really high fidelity models of the Earth's surface that catch subtle features. And that high fidelity model of the Earth's surface is really what's essential for modeling some of those root cause components of geohazards like hydrology. Right now, as it stands, LiDAR is still the best technology on the market for creating models of the Earth's surface, or digital terrain models and digital surface models. However, as SAR expands in its constellations and the bandwidths available, more and more bandwidths will provide better canopy penetration and vegetation penetration, and we expect for SAR to become increasingly useful for terrain modeling in the future. Right now, while SAR is viewed as an additional factor is the cost effectiveness, right? And SAR is viewed as a cost competitive option for modeling geohazards alongside LiDAR. If you were to go out and not do so right now, how we make LiDAR cost competitive with SAR is we offer a cost sharing program that allows us we capture a large extent of area with LiDAR that includes operations and infrastructure for many different companies. So those companies have access to cost sharing benefits that pull costs down of LiDAR collection and make that LiDAR data cost competitive with SAR data. And, we probably, as time goes on, we'll see if the costs of SAR go down as more constellations go up, but you do have the added cost with SAR is that arise from needing to task a satellite twice in order to get the two bandwidths to run interferometry and extract information. And then you have to run the interferometry process, which is still that other segment, the interferometry process of extracting information from the wavelengths is still an emerging technology and kind of the Wild West, if you will. While LiDAR's been around for a really long time. And while we're still innovating in that space, there are dependable processes through which you can extract information from LiDAR point clouds. So that's kind of the skinny on LiDAR versus INSAR.
Cool. Yeah, I use INSAR on subsidence and tunneling projects, and yes, when it's out in the open with persistent scatterers. But when we examine right-of-way corridor, we proposed with INSAR vendors about right-of-way corridors out in the hills and the heavily vegetated areas in the forests and around dams. It wasn't really suitable. As you said, there's the vegetation issues, but broad area and also being able to look back in time. I see a lot of promise about SAR. I think we're going to be planning a webinar on that in the near future. So I want to get to some other questions. A question for Jeff. I'll have to paraphrase this. Jeff, with your eye on the industry, are you seeing the adoption of more of this? People putting these programs into place?
I'm going to have to say yes. I don't have a lot of specific data, but it's, I think I explained to the panelists when we met and did a dry run. Technology, I mean, the need forces the development of technology, right? It's a forcing function. And we've seen, as I tried to illustrate earlier, and the panelists have also illustrated here, the drivers for safe operations are increasing every year, whether it's ESG, and people are going to rail about your, releases into the environment, be they methane or be they product, other crude or refined product, whether it's the safety advocates, whether it's the media or whomever. I think the costs of failure in the pipeline world have grown year by year, and that has driven the development of technology. And I think the smarter operators, and typically, the early adopters are better financed, right? But as that comes in, the cost of technology also drops and it really expands much more widely. So yes, I think that clearly people, particularly after they get religion after a really bad accident, and then almost anything, they don't want to see it happen again. So that pretty much anything's for a go at that point.
Excellent. So we're kind of running over the planned time, but I'm seeing a lot of great retention in the participants. People are hanging in here. And so we got a lot more questions to go through. And if it's okay with y'all, I'm just going to keep going on these for a while. There's a, question. I'm going to put two questions together. Are there formal guidelines that form the framework for implementing a temporal LiDAR change detection program? And related to that, what are like density specifications that you adhere to when you're doing this?
So as far as the density specifications, for the LiDAR data we acquire that at 20 ppm or pulses per meter.
Okay.
Again, through R&D, we really determined and found kind of the right tool for the job, right? For the type of discrete analysis that we do on this data, that's the fidelity really that meets the mark and also allows us to process very rapidly. In regards to any, what was the first part of the question?
Are there formal guidelines? Well, I don't know if there are because I've been looking for them, but are there formal guidelines, or did you really come up with your own guidelines?
Yeah,
fit
and
for purpose?
Kat may want to, add to this as well, but to my knowledge, not formal guidelines per se, but it has been a lot of collaboration between Teren and the industry to really determine, what is the current procedure. A lot of this comes back to handing off these analytics to an integrity team, to geotechnical experts, that then take that and implement their process and procedure and how they categorize and prioritize, and then therefore go and prescribe their mitigative efforts after the fact. Kat, anything to add to that?
Yeah, I'll add that PHMSA has released a couple of advisory bulletins within the last few years that specifically address landslides, external force threats, river depth of cover threats, and so forth. And those advisory bulletins specifically call out the use of new technologies such as LiDAR or synthetic aperture radar as qualifying methods for implementing, acceptable methods for implementing right-of-way integrity management patrols and monitoring programs. So while there hasn't been no prescription, if you will, for the use of these technologies for achieving excellent right-of-way integrity, the technologies have been explicitly approved.
Oh, okay. And as Jeff said, the technology led, the acceptance. And actually, I got to go back a little ways. Years ago, I was in charge of for XYHT magazine selecting 40 outstanding geoprofessionals under 40, and one of them was, Tobias Kraft, co-founder and CEO of SolSpec, which is now Teren. And I remember talking to him, and he said, one of the reasons that he kicked off into this segment of the industry was that the confluence of the technologies. There's so much geodata available now, so many ways to represent it and analyze it. And although LiDAR had been around a long time, and airborne LiDAR, the usability and the tools to analyze it. So it all sort of converged together. And, this is very timely what's going on. So to another question here, someone's asking for a link or a follow-up email to provide resources for reference for implementing a change detection program, like published research, case studies, etc. I guess they should contact you offline.
I'll suggest that folks stay tuned to a forthcoming white paper we have on that subject. That and alluding to speaking to the prior question that we got on, are there any regulatory frameworks or is there any guidance out there on change detection, geohazard management? That paper will also cover that, right? Our white paper will focus on implementing an effective change detection program that also fulfills compliance obligations that come from several different regulatory bodies. So.
Oh, great. So a question here, the boots on the ground, is your analytics, how's your analytics compared to boots on the ground? Will your analytics reveal threats that the inspectors might not be able to pick up? Okay.
Yeah, certainly. And, I'll reference Bryan's component of the presentation and the case study that he presented, where their boots on the ground inspection had identified, I believe, 246 different slips in this area where they were focusing. And then upon prescribing the LiDAR acquisition and subsequent analytics from Teren, an additional 12 were found that had not been found due to that visual inspection. And it's just often a matter of, again, LiDAR being able to strip away everything and presenting a bare earth surface at a high fidelity, a 40 centimeter resolution raster cell size, right? To be able to tease out information that the human eye often, just misses. So that's where I think a lot of the industry has found the value here is this technology provides something that's not going to replace boots on the ground. It's not going to replace your geotechnical engineers, but it's going to provide data that often you can't get to just from the naked eye.
Oh, okay. Thank you. Well, okay. Two identical questions here. What's your turnaround time from acquisition to delivery?
Yeah. Well, and that's a great question as well. That's something, that again, I mentioned I get to work with a lot of brilliant people, and we have some pretty brilliant folks that have put pieces in place around high performance computing, parallel processing, and a bunch of stuff that goes over my head, frankly. But to answer that question, what that has enabled us to do is, and I believe a metric was once provided to us around 60 times faster than industry average as far as the processing of that data. Okay. Traditionally, LiDAR data, has scared a lot of people off. It's just so big, so complex. It takes a very specialized skill set to massage that data, to turn that into something that then could be handed off for analysis. Our ability then to take that, process it very quickly, the raw LiDAR data, down into these key core derivatives, digital terrain model, that bare earth surface representation, digital surface model, the first return that includes the trees. And then the analytics component, again, I may have mentioned it at one point, the automation through machine learning, AI, enables that process to happen very rapidly as well. Again, traditionally, this is a engineer sitting down with data to work through that, where we can implement the automated generation of these analytics. There's still a component of human eye for Q&A and the delineation of those geohazards, but that is, something that has really been a bit of a game changer, is the ability to turn this data around so quickly, because timeliness is often very important when it comes to, risk management and integrity management.
Okay, and you actually covered this question about, are you doing like DEM comparisons for the 3D analysis on it? That's good. Mm-hmm. And a question here that I wanted to ask as well. Can you align your data with the other sensors, inline strain gauges, IMUs, accelerometer data? Yeah, great question. I talked a little bit about depth of cover previously, and I'll use that as an example. One of the analytics, and again, we didn't go into great depth as far as all of the analytics that Teren generates, wanted to keep this more educational, but the depth of cover analytic that we run is something actually that requires that second input, that ILI IMU data, so that we can run a comparison to look at what bare earth surface elevation shows comparative to what that IMU data would show. So that's one example where, again, we're coupling in different data sources. And, behind the scenes, whether it be looking broad brush essentials or more specific at the LiDAR-based RIM premium, there's a number of data inputs that are often being utilized, right, in this geospatial analytic comparison, right, to tease out that relevant data. There's been talk as well about, how can we integrate other geotechnical tools, perhaps that are on site, on the ground. And that often is a component that's a follow-up, perhaps, where a geohazard is identified. There's significant risk there, perhaps through change detection, we can see some movement that may then denote, let's get some tools in place on the ground for some additional real-time monitoring. Does that help? Yeah, that definitely covers it. Segueing into
Gavin, just quick. Do you,
Yeah.
do you think that question might be also answered like getting at, how does this data integrate with other like inline inspection tool,
Yes.
inline inspection data? So we are also currently looking at applying linear referencing to our data, to our geohazards and our problematic hydrology instances. So that's something that's currently in the queue and underway right now that we expect to be able to deliver to clients in the near future, that will really facilitate easy integration of these geohazards data sets and related data sets into current broader risk management programs.
Yeah, I was just going to jump in on that too, Kat. So thank you for doing that. Because if you look back at integrity management, that's one of the core principles, is to integrate all your sources of information. And of course, you're going to have to synchronize those geospatially in order to do that. But it really opens up a big window to an operator when they can bring all those sources together and see, if there's an additive effect between them, or if they have multiple indications that that's a high risk segment that they need to address. So good point, Kat.
Okay, great. So this, well, it sort of segued into another question, which I have as well. I do survey work for water, sewer, and power utility. And that's the other question is, we're focused on the oil and gas here with the examples, but the applicability to other, infrastructure and right-of-ways, I would imagine. You want to talk about that, Jake?
Sure. Yeah, certainly, as I mentioned before, yes, we focused on pipelines in these use cases, but really any asset and beyond even just an existing asset, there's certainly applications where we work with folks. Anytime there's any type of civil engineering terrain-based information that might be needed, these terrain products that could be 1 foot, 2 foot contours, looking at that elevation data on a particular site, looking at vegetative management along a right of way that may not be a pipeline, it may be utility based, looking at the encroachment of vegetation, looking at structures that may or may not have been identified prior using other means, where again, something like LiDAR can penetrate a canopy to find a structure perhaps. So number of different applications within solar site development, within insurance, and Kat, who heads up R&D, may want to add some more flavor to that for some of the other use cases that certainly we're looking at and working with folks in the industry.
I think you did a great job covering it. I think we see this technology being applicable to certainly all types of right-of-way corridors, long linear corridors, transportation ways, and the broad swath of utility types that you spoke of, Jake, but also other types of assets and infrastructure as well, right? Communities and municipalities, and broader kind of landscape level planning. Physical risk threats are not discriminant when it comes to what type of assets they threaten. And if there's an asset that's in an area prone to landslides or movement, it behooves us to put a plan in place to manage that.
Okay. We still got a lot of questions. If it's okay, I'd like to just run over here. It's a great interactive conversation going on. About Teren's presence in Canada, someone's asking specifically about some production areas like in Alberta and BC.
What was the question? Sorry, Gavin.
Your Teren's presence or ability to work up in Canada and some of those production areas. Yes,
we have done some work up in the Canadian Rockies, very similar to the work we've done down here in the US and in the Northeast. And yes, so the same concepts apply certainly when it comes to LiDAR acquisition. And of course, there's some logistics involved, whether we're getting a US-based crew and aircraft across borders or working with other local acquisition providers as well. You know, with, as I mentioned before, Teren can consume LiDAR data. It doesn't necessarily have to be the data that we collect. So there's different things we can do there. But to answer the question, yes, we have actually done some work up in Canada and have some ongoing discussions as well with other operators up there.
Okay, and questions about, you know, how is the data shared or presented with the client? Are you using it like in a cloud application, a client log into a web-based PDFs, share the actual analysis raster data, anything like that?
Great question. Yeah, so there's actually a number of ways in which this data is delivered to the customer. You saw some screenshots in there from a GIS perspective. So we actually include in our deliveries a 3D viewer, so a GIS web-based 3D viewer that includes the foundational raster data, the terrain products that are generated, derivatives from that LiDAR data, as well as those vector-based files, such as the geohazards and some of the hydrology components, other analytics like that. So that's all put into a, you know, really out-of-the-box web viewer. But, you know, going back to a previous question about integration of data and GIS platforms, again, predominantly our users are leveraging the Esri environment, and we can actually stream this data, for example, into an Esri portal environment. So we have Esri portal compliant streaming services, both for vector data and raster data, that we can stream directly into a client's GIS environment. And of course, the data as well can be loaded up to an FTP site, or even in some cases go old school and put it on a hard drive and ship it. Different ways in which we can get that data in the hands of our customers. And there's some ancillary data as well, some you know, KPIs and different components of delivery that really do a good job of summarization of what was found in that particular acquisition. So yes, there are some PDFs and some tabular data that would go along with that as well. But predominantly, it's a very geospatial friendly. You know, the information is very well presented through geospatial data. And so that's the typical format that we deliver and typically what's consumed and utilized on the back end by the customer. Okay, great. And yeah, a comment question from Greg about hunting for those guidelines. Yeah, I'm looking forward to seeing your white paper. And also, I got kind of interested in this for my day job. So what I want to write up a case study, you know, of this, you know, pipeline external threats. So I've been in touch with Stacy with your group to do a case study. I'll probably write it up and put it in GoGeomatics. And I'm going to wrap it up. There were a number of questions asking about the LiDAR acquisition. That some of the more technical ones, I encourage the folks to get in touch with you offline. But in general, I understand that you use a manned fixed wing aircraft rather than drones. And of course, I can speculate. I know firsthand that it's sometimes difficult to use a drone like in a city or over people, whereas hey, aircraft with LiDAR on them, you can fly them almost anywhere. So
leverage those economies of scale that enable LiDAR to be cost competitive and accessible. We fly 2,500 square miles of pipeline in an instance easily, right? And to do that, there's no way drones would touch it. And drones are quite expensive. So yep, we used fixed wing manned aircraft.
Yeah, I mean, yeah, drones are expensive in reality in operation, covering large areas. I just went over a case study with someone in Australia about drones over mining areas that they said, my God, if I try to do more than 10 square kilometers a day, it's going to be pure hell. So I do have to wrap this up. Any unanswered questions will be answered by email. Wanted to thank everybody for joining us today, and please give us ideas about future webinars to do. And want to thank Teren especially for sponsoring today. And Jeff, thank you for coming on. If you have any closing comments, Jeff, I'd like to give you the floor. Oh, I think you're muted.
Well, I very gratefully said, thank you for inviting me. I always learn something when I do these engagements, and that's what makes me a happy guy, learning, right?
Cool. And me as well. That's why I enjoy doing these. Thank you, Connect Me, for directing this. We'll see you all again sometime in the near future. Thank you. Bye.
Thank you.
Thank you, everyone.